All right. If you would, please turn into your textbooks, and we're going to be on page 445. We're going to be on page 445 inside of your textbooks. All right. We are going to skip problem 1, and we're going to look down at problem number 2 here. Let that filter for a second. There we go. You just solved a problem that involves setting up and writing a two-step inequality. We'll get to that later. Let's compare and contrast the strategies and solutions of an equation and inequality that are similar in structure. Describe the steps you would take to solve the equation 3x minus 2 equals 7, then solve the equation. All right, so I'm going to rewrite my equation right here, equals 7. And then as I do each individual step, I'm going to tell you the steps over here off to the side. Okay, well, my goal is to isolate x. I want x by itself on one side. So I'm going to do the opposite of what I see. So right now I am subtracting 2 from the x. So I'm going to add 2 to both sides. So my first step is add 2 to both sides. Okay. Now I'm going to solve from here. Well, negative 2 plus 2 is 0. So I'm left with 3x on the left, and 7 plus 2 is 9. Okay. My goal is still to get the x represented by itself. So I see right now that I am multiplying between 3 and x. So I'm going to divide the left side by 3. What I do to one side, I must do the exact same thing to the other. So when I added 2 to this side, I have to add 2 here. I need to keep everything balanced, which is what this equal sign here means. So I'm going to divide by 3 on the left side and divide by 3 on the right. So my next step is divide by 3. Okay. 3 divided by 3 is 1. So I'm left with 1x is equal to 9 divided by 3 is 3. So x is equal to 3. Okay. Well, let's take a look at number 3 here. So number 3 says a set of possible solutions for each inequality is shown. Circle the solutions that make the inequality true. Then list 3 additional solutions to the inequality. Okay. So I need to know at what point does this make this inequality true? So it says to determine if a value is a solution to an inequality, use substitution. If the resulting inequality is true, then it is a solution. All right. So letter A, I have 3x minus 2 is less than or equal to 7. Okay. So I want to go ahead and start plugging in. Well, let's plug in 0 and check 0 first. That seems to be a pretty easy number. So I'm told to use substitution to check this. Well, 3 times 0 is 0. 0 minus 2. I'm left with negative 2 is less than or equal to 7. Now, think of this. Is this inequality? Is it eating the bigger number? Well, no. Negative 2 is smaller than 7, so 0 is not correct. Okay, let's try 3. Let's go to 3. So 3 times 3 minus 2 less than or equal to 7. Well, 3 times 3 is 9 minus 2 less than or equal to 7. 9 minus 2 is 7 less than or equal to 7. Well, here's where it gets a little interesting. I have 7 is less than or equal to 7. Well, 7 is equal to 7, so 3 is a solution to my problem. Okay, well, what happens if I were to put 4 into this inequality? If I said 3 times 4 minus 2 less than or equal to 7, 3 times 4 is 12 minus 2 less than or equal to 7. Well, 12 minus 2 is 10 less than or equal to 7. Well, look, 10 is bigger than 7, and I'm opened up towards the 10, so 4 is going to be a solution. Well, if I know that 3 and 4 is, if I keep going up in my number line, I know that all of these numbers here are going to be a solution to my problem. Okay, some other examples of solutions would be 8, 10, 12. Anything bigger than 3 would be a solution to my problem. Okay, All right. I have 3x is less than or equal to 9. Okay, if I were to plug in 0, okay, let's start at 0 for a second, less than or equal to 9, well, I have 3 times 0. Well, wait, is it bigger than 9? No. Well, let's try 3. I like to go up to 3. So 3 times 3, less than or equal to 9. Well, 3 times 3 is 9. Well, does 9 equal 9? Yep. Let's try 4. 3 times 4. 3 times 4 is 12. Is 12 less than or equal to 9? Is it greater than 9? Yep. So it looks like 4 is going to be the answer. What if I plugged in 5? Well, 3 times 5 is 15. That's bigger than 9. 3 times 6 is 18. 3 times 7 is 21. All of these numbers that are 3 and bigger are going to be possible solutions. So it looks like I can use 8, 10, and 12 as a solution as well. Okay. All right. What about x is less than or equal to 3? Well, if I were to plug in 0, well, I know 0 is not going to be bigger. 1's not going to be bigger. 2's definitely not bigger. What about 3? Well, 3 is equal to 3. Is 4 bigger? Yes. 5, 6, 7. Looks like 7, then 8. I can add 10. I can have 12, so on and so on. So what do you notice about the solutions you circled in questions 3, parts A through C? Well, all the solutions, all these solutions are the same. Okay. What do you notice about the 3 additional solutions you wrote for each inequality? The solutions I wrote for each inequality were all greater than 3. So all additional solutions were all greater than 3. Okay. So compare the sequence of the 3 inequalities to the steps you used to solve the equation in question 2. What do you notice, and explain your reasoning? Okay. So I noticed that the 3 inequalities, so these 3 right here, they are all equal to one another because all of my solutions are the same. So all inequalities are the same with the same solution, showing I can use these same steps to solve inequalities as I would equations. Because I'll let you just write that down. Because let's take a look here. My first step, I have this equation, 3x minus 2 is equal to 7. Well, all I did was just replace that in the exact same equation with inequality. Okay. Our first step was I added 2 to both sides to have 3x is equal to 9. Well, look, 3x is less than 9, or less than or equal to 9. Then I divided by 3 to get x is equal to 3. Well, I have x is less than or equal to 3. I think that's greater than. I get the number names mixed up. So then I have x is greater than or equal to 3. I use the exact same step. So each individual step that I had here was shown here in inequality. So noticing and seeing that all 3 of my solutions are the exact same for all 3 steps in my inequality, I'm able to solve inequalities the same way I would solve equations. Okay, so let's go ahead and graph this inequality. So I am told that x is greater than or equal to 3, okay, or less than or equal to 3. Meaning if I have a line on bottom, I'm going to start at 3, and I'm going to have a closed dot at 3, meaning I can include 3 into my problem. Okay. We noticed that any number that was greater than 3 was a solution to my problem. So I'm going to shape everything to the right on my number line to signify that every single number bigger than 3 and 3 will be a solution to my problem. All right. So you can check your solution to an inequality by choosing a value that is in the solution set and substituting it to the original inequality. If that substituted value makes the inequality true, then you have verified a solution. So choose a value from the solution set of the inequality 3x minus 2 is greater than or equal to 7 and verify that it is a solution. Okay? All right. So let's see here. Do I want to do number? Yep. All right. So let's choose 8. So we're going to choose 8 here. So I'm going to have 3x minus 2 here and 7. I'm choosing 8. So I'm going to plug in 8 for every x that I see minus 2. So equal to 7. Well, 3 times 8 is 24. Minus 2 less than or equal to 7. 24 minus 2 is 22. Well, is 22 bigger than 7? Is my little alligator here eating the bigger number? And it is true. He is eating the bigger number. If you guys have any questions on that, please let us